This is a recap from our last module. The basic idea was that we were using a carrier wave, and then on top it we were putting a modulated signal, and we would use that carrier modulation to transmit the signal. And if you remember, if the spectrum of our information signal, A of f, looked like this, we know that cosine looks like this, and we did a convolution of these two which led to this spectrum. So you should remember that from last lecture, and we're going to use the same concepts again in this lecture, except we're going to start to look at some different ways that we can modulate and demodulate signals in the analog domain. All right, so the first one I want to talk about is a non-coherent receiver. So this is the, by the way, I should mention that this right here is a double sideband because we have two sidebands, right? And if we want to receive that, a simple way to do it is with a non-coherent receiver. And what do I mean by non-coherent? Non-coherent means I don't know anything about this carrier wave. I don't know its frequency. I don't know its phase. All I know is that that has this nice little analog modulation on it. And so a very basic one is a simple rectifier where we're just peak detecting. And you can see where this just peak detects and we get our signal off the back. Now, if you use this circuit exactly as it is, you would just have a DC voltage on the top here. In reality, there is some load off here that discharges the cap so that the signal can fall over time. But the basic idea there is we're just doing a peak charging. And this is nice because, like I said, we don't need to know anything about the carrier. And back when I was a kid, we used to build radios this way. And so here is an old crystal radio kit. You can see some coils right here. And here is our special little diode. Okay, so we can do envelope detection there. And you could receive AM radio even today with this simple modulator. But there's a lot of drawbacks. As we'll see in a second, one of the problems is that I need this carrier in order to have a clear envelope. And so I've got a lot of carrier power that I have to transmit in order to get that envelope. And the other aspect is really the bandwidth that I transmit is directly related to the bandwidth of my signal, which may sound like a perfectly good idea. However, we'll talk later in our notes about the idea that if I find a scheme that can use a larger bandwidth, I have the opportunity to actually improve my signal-to-noise ratio. So that's one of the reasons why FM radio is a better clarity than AM radio. So that's a non-coherent receiver for double sideband. So the next we're going to talk about is suppressed carrier double sideband. And the basic idea of this is if you look here at our signal here, the big difference between this and the previous is there's no DC component, right? And if there's no DC component, when I do my convolution, I will end up with my signal here, and you notice there's no carrier, right? And that's useful if I don't want to transmit the power in my carrier, so I save a little bit of power. We'll see in a second that that actually poses some problems for us if we have absolutely no carrier. And the reason is later on we're going to talk about something called coherent detection. And coherent detection wants to know what that carrier was. And it's really hard to figure it out if there's nothing here. So sometimes what people do is they actually go in and they put just a little bit of a DC component here so they can get a little bit of a carrier right here. And the reason we'll use that is we'll use this for coherent detection later on. So basic idea is to reduce the carrier as much as possible, but sometimes we leave just a little bit so that we can recover what the signal is. Another thing that is a problem with suppressed carrier is if you remember in our previous slide, we needed this carrier to give us a nice clean amplitude. If you remove the carrier, you actually end up having some challenges with recovering this carrier. And in our lab, we'll actually do an example where we try to use an envelope or a non-coherent receiver on a suppressed carrier signal, and you'll find out that you don't get the original signal back. So the suppressed carrier is good for power, but it's going to require a little bit more complicated of a receiver. And so let's go ahead and talk about coherent receiver. And the basic idea is, here's the signal that we've just transmitted. And I'll just go back in the slide so you can see it's just this signal right here. And now what we're going to do is we're going to multiply it by cosine omega ct. And note omega c, omega c. In this example, it's called a direct conversion. And that just means that we're just using the same frequency to downconvert. Later on in another module in the future, you'll learn about two-step conversion where you may downconvert it to a middle frequency. But for right now, just notice that this omega c is deliberately chosen to be the same as there. And what we do is we're going to do the convolution, once again, between these two. And what that does is it takes this here and it plops a copy down there, and it's going to plop another copy down here. So if you will, I think I can draw this in two different colors. I'll do blue. This goes here, and this goes there. I'll switch colors here. I'm going to go to green. This one gets transferred to here, and this one gets transferred to here. That's with this one, and just to be clear, this is the blue one. And what you're going to see is that we actually have two copies that land on top of one another right at 0. So you actually have twice the power right around 0 than you do at these two higher frequencies. And all we would do is we would just filter these out with a simple filter so that we end up with a perfect reproduction of, if you go back, our original signal that we wanted to transmit. So it's basically doing an up conversion step, if you will, and then we just simply do a down conversion step using exactly the same thing. And the key thing for the coherent receiver is, as I mentioned before, we need to know what this is. So if we don't have any carrier, there's nothing here, we're not going to be able to really determine what our original carrier is. There are some tricks we can do to try to figure it out from what's around this data, but oftentimes we will try to simply leave a little bit of that carrier in there so that we can recover it.